Karibu Ibrah Network Lab. Hii ni kozi kamili ya Cisco Certified Network Associate.
Okay, this is IP address video part 2. The previous video was much wrong, so I decided to make a partition. Na kwenye video iliyopita tulidiscuss vitu vingi sana, but kuna some of the few things ambavyo hatukuvidiscuss which are very much important na unatakiwa vijue. Okay, here is the chapter and these are the content that we are going to pass through. Tutaenda kuangalia jinsi ya kufind the maximum number of the address, the network address, the first usable address, the last usable address, the broadcast address. However, the network address pamoja na broadcast address we have already discussed in the previous video. But in this video, we are going to do some of the revision about the network address and the broadcast address. Then finally, in the next video inayofuata tutakwenda kuangalia jinsi ya kuconfigure IP address on the Cisco devices. Okay, let us have some revision here on what we discussed in the previous video. So ukiangalia vizuri, hii ni chapter ambayo tulidiscuss kwenye video iliyopita, the IP address part 1 video. So as we said, so kwa mfano hapa tuna network ya 192.168.10.0/24 network. The /24 means the first 24 bits represent the network portion, then the rest 8 bits represent the host portion. This remember the range of this class is class C network. This is the range of 192. Ni range ambayo inapatikana kwenye class C. So remember this. And the subnet mask ya class C it is 255.255.255.0. It is here. This is the default subnet mask of class C. So natakiwa pia remember hichi kitu. Default subnet mask, the network address ya class C inaanzia range ngapi mpaka ngapi. Then we had a discussion about the class B network, which is a /16 by default. So /16 manake the first 16 bits that represent the network portion, while the remaining 16 bits that represent the host portion. And the default subnet mask ya class B network is 255.255.0.0. Remember this one also. Also we had a discussion about the range of class A, ambayo range yake inaanzia 1 mpaka 126. So once you see 10, it is within the range of class A. So as we said before kwenye previous video, kama once you see /8 means the first 8 bits that represent the network portion, while the remaining 24 bits that represent the host portion. So as you can see hapa, once we convert it into binary, 10 is equal to 0, 0, 0, 0, 10, 10. Then 0, once you convert to binary, is equal to 0, 0, 0, 0, 0, 0, 0, 0, dot 0, 0, 0, 0, 0, 0, 0, and so on. As we said before, the computer doesn't understand the real number. It only understands the binary number, binary codes. And once you remember, tulisema kwamba 0 means off, and 1 means on. So let us go to the main topic. As I said before, in this chapter, we are going to focus on how to find the maximum number of the address or hosts that are found per each network. Then we are going to see the network address, the broadcast address, the first usable address, pamoja na last usable address. So let us be very careful here. Let us consider hii network hapa 192.168.10.0. So as we said before, since this is a class C network, it is a /24 network. So /24 network means the first 24 bits. Ukiangalia hapa zenye rangi nyekundu, these are the first 24 bits. They do represent the network portion, while the remaining bits, this one with the pink, they mean is in color hii hapa ya blue, they represent the host portion. So the host portion ya hii network yetu ni 8 bits, since it's a /24 network. So /24 network represents 24 bits, the first 24 bits that represent the network portion, while the 8 bits ambazo zimebakia zina represent the host portion. So through this range, yeah, 192.168.10.0/24, we are going to get the address from 192.168.10.0 mpaka 192.168.10.255. So through this range of /24 network, we are going to get the total number of the address from 0 to 255. Okay, let us remember one thing here. As I said before, if you see the host portion, the all values are 0 in the host portion. Ukiona kwenye host portion mfano ni 192.168.10.0, this is the /24 network. So the host portion now here is, we are talking about 0 here. Hii octet ya mwisho hapa. This is the host portion in the /24 network. So tukiona kwenye host portion all are zeros, this represents the network ID. So whenever you see the network with a /24, but in the host portion, it have all zeros, it represent this is a network ID. Remember this, and I'm repeating once again myself. In the network, for instance, for this network here, 192.168.10.0/24 network, since it is a /24 network, maana yake ni kwamba bit 24 za kwanza, the first 24 bits represent the network portion, while the remaining 8 bits they represent the host portion. Now, once you see kwenye host portion umeona zote ni 0, all are 0, that represent the network ID. So remember that. And in the another formula here, kwenye host portion also ukiona all portion, kwenye host portion also ukiona zote zina represent by 1, but that represent the broadcast ID. So once you see here from our network, once we convert this number 192.168.10.255 into binary codes, so in 255.255 it is going to give us the bits of all 11111111. So whenever you see in your network the host portion, it is represented by all ones, manake ina represent hiyo ni broadcast ID. So remember, as I said before, the network ID and the broadcast ID, hizi network address haziwezi kuwa assigned kwenye any network device. So remember this, once you see the network ID and the broadcast ID, this address, they cannot be assigned in any network device. Okay, so now let's move on here. We are going to find now the first usable address in the host portion. So let us come back here from our network ID. Our network ID yetu ni 192.168.10.0. Once we convert these numbers into binary codes, once we convert 192 into binary code, unapata 11000000. Then once we convert this 168 into binary codes, tunapata 10101000. And also to convert hii 10 into binary code, tunapata 00001010. And once we convert 0 into binary codes, we're going to get also 00000000. It is 8 bits. So we have tuna 4 octet ya kwanza, octet ya pili, octet ya tatu na octet ya nne. But for this scenario here, we are going to exclude hizi network address yetu, manake /24 is na represent the 24 bits na represent the network portion. So we don't deal with this network portion, since we are trying to find the first usable address. So the first usable address, it is going to be assigned kwenye host portion. So kwenye host portion is where we are going to assign the first usable address na tutakwenda kupata the last usable address. So we are going to focus with our host portion. So the host portion now, it is 00000000. It is 8 bits. It's all 0. So for us to get the first usable address, we just only add 1 to our host portion. Look here. It was 192.168.10.0 ambapo tuliconvert into binary ikawa hii hapa address. So sisi tunataka tupate the first usable address kwenye hii network. It is very simple. Una add only 1 here. So ukiangalia hapa, you add 1 in the host portion. So it is going to be like this. 110000. Hizi huko hazibadiliki kwa sababu hizi first 24 bits na represent the network portion, so zitabakia kuwa vile vile the same. So ukiangalia vizuri za addresses za hapa na hapa ni the same, but hii last octet ya 4 ambayo kwenye host portion imechange, imekuwa ina 1. So as I said before, so for us to get the first usable address tunatakiwa to add 1 kwenye host portion. So I added 1 here, so it is going to be now, ukiconvert this kwenye decimal number utapata 192.168.10.1. It's very simple. Then once we want to find the last usable address, the last usable address we come from the broadcast address here. Since we said kwenye hii network inaweza katupa address kuanzia 0 mpaka 255. So 255, this is the broadcast address kwa sababu ina contain all 111111 if you convert kwenye binary. And we remember binary address cannot be assigned kwenye any network device. So it is very simple. From our last address ambayo tutapata kwenye hii network ya /24 ambayo ndio broadcast address, we just minus 1. So unakuja una convert this into binary codes. After you convert it to binary codes, unaangalia hizi host portion. In the host portion here, you just minus 1. So you start here and then you minus 1. So ukitoa moja hapa, ukiangalia hapa, we have minus 1 from our host portion. This is a broadcast ID. So on the broadcast ID, I have minus 1 here. So I'm going to get 11111110. So 0 is what I just minus 1, then I get 0. So therefore, this is going to be my last usable address kwenye network ya 192.168.10.0. So ukishatoa moja una convert into decimal number. So once you convert 11111110 into decimal number, you are going to get 192.168.10.254. So .254 ndio last usable address kwenye network yetu ya 192.168.10.0. Very simple. Let us look the class B network now. The principle ni ile ile. We convert it into binary code first. So to convert it into binary code. And this is a /16 network. So manake the first 16 bits, as you can see here, the first 16 bits that represent this is a network portion, but hizi bits zilizobakia zina represent the host portion. So here is where we're going to assign our address in the host portion. So through this range here, 172.32.0.0/16, we are going to get address mpaka 172.32.255.255. And as I said before, once you see in the host portion inakuwa represented by all 0, this represent the network ID. And once you see in the host portion, it represent all 11111111. That represent the broadcast ID. So remember this. Whenever you see in the host portion umeona kuna 111111, basi manake hiyo address ni broadcast address. It cannot be assigned to those network device. And whenever you see kwenye host portion kuna 0000000, it doesn't matter, ni /16/24/8. But you just focus in the host portion. Whenever you see 00 in the host portion, it represents the network ID. Whenever you see 111111 in the host portion, that represents the broadcast ID. So it's very simple. We come here from our network address yetu ni hapa, si ndio? 172.32.0.0. So we need to get the first usable address. Very simple. In the last octet yetu ya mwisho, the first octet, we just add only 1. So as you can see here, nime add 1 kutoka kwa hii octet yangu ya mwisho. So it is 00000001. So this one, once you're going to convert into binary, unakuja kupata the first usable address ya network ya 172.32.0.1. So it is very simple. So the first usable address ya 172.32.0.0, it is 172.32.0.1. Hiyo the first usable address ya kwenye network yetu ya 172.32.0.0. The last usable address, it is very simple. Unarudi from the broadcast ID to come here. From the broadcast address, it is represented by all ones, which are 8 bits, 1111111. So from the last octet ya mwisho, you just only minus 1. So kama unavyoona hapa, we just minus 1 in our last octet here. So here we have minus 1. So kisha minus 1 hapa itakuja hapo, umeona imechange. So imekuwa ni 11111110. Then finally after you kisha minus imekuja 0, you just convert it into decimal number. So once you convert this 11111110 into decimal number, tunakuja kupata hii hapa address ya 172.32.255.254. It's very simple. Then finally, let us see in the class A range of class A. For the class A also is very simple. Convert your network address into binary codes. Then since we are finding the first and the last usable address, we will be focused only on the host portion. So in this network, our host portion ni hizi hapa, biti kuanzia octet ya pili, ya tatu na ya nne. This is our host portion. So for us to get the first address, we just only add 1 in our last octet. So umeona hapa tume add only 1 here. You add only 1, this you're going to get the first usable address. Once you want to get the last usable address, you load from the broadcast address, then you minus 1 from your broadcast address. Then after you minus 1, you have minus 1, gonna convert your binary bit into decimal number, then you're going to get the last usable. So in this chapter, we are going to learn on how to find the maximum number of the host per network. So whenever you are going to given any network address, unatakiwa uweze kujua kwamba kwenye hiyo network yako ina uwezo ikakupa jumla ya address ngapi, au hiyo network address yako au kwenye hiyo network iliyokupa wewe ina uwezo ikaprocess how many numbers of the host, jumla ya device ngapi zinaweza zikawa assigned kwenye hiyo network. So there are some of the tips and techniques that we are going to see and cover in this chapter on how to find the maximum number of the host per network. So let us consider our network here by 192.168.10.0/24 network. Network /24 network ina represent au inamaanisha kwamba the first 24 bits ina represent, this is the network portion, while the remaining bits ambazo ni 8 bits zina represent the host portion. And the chapter says how to find the maximum number of the hosts per network. So we really means we are going to focus in this fourth octet ya mwisho. So tutakwenda sana kufocus na hii octet ya mwisho ambayo ni host portion for this class ambayo ni /24 network. Na usikariri kwamba kwenye kila network utakuja kwenye hii octet ya mwisho na kutafuta hizo maximum number that are available per network. No. The slash number means kama ikiwa /24, /16 au /8, it means hizi zina represent tofauti. Kwa /24 maana yake kwenye host portion inakuwa represented by bits, only 8 bits. Ikiwa /16 maana yake kwenye only 16 bits zina represent the host portion. Lakini pia ikiwa /8, which means the 24 bits zina represent the host portion. All out tutakwenda kuzikava zote hizo. Tunakwenda ku start from the class C, then class B, then class A. So from this our class C network here, since we say we are going to find the maximum number of the hosts per network, the formula is 2 to the power of n. N represent this the number of bits that are available in the host portion. I'm repeating once again, the formula is 2 to the power of n. N represent the number of bits that are available to your host portion. So for this instance, our network is 192.168.10.0/24. So our host portion inakuwa represented by only 8 bits ambazo ni hizi hapa. Why? Because it is a /24 network, which means the first 24 bits represent the network portion, while the remaining bits represent the host portion. So we are going to take these 8 bits. So ukiona hapa nimechukua 2 to the power of n. So remember this, the host portion is where we are going to assign our address to our network devices. So our network devices, they are going to get an address from this part here, from this host portion. So our host portion contains 8 bits. So we take 2 to the power of n, 2 to the power of 8, which is 8 bits. So we're going to get the total number of 256. But this is not enough. Why is not enough? Kwa sababu we have calculated the total number of the all address. We have including the network address pamoja na broadcast address. And as we have said before, kwamba the network address pamoja na broadcast address, they cannot be assigned to any network device. So we are supposed to exclude them. Now the formula become here, it is 2 to the power of n minus 2. So hii mbili ina represent the network pamoja na broadcast address, which we are going to be excluded. So as you see here, very simple, 2 to the power of n minus 2. So 2 to the power of 8, which is 256. Then once we minus 2, tunapata 254. So 254, these are the total valid address ambazo zitakuwa assigned to our network. I'm repeating once again, the 254, this is the total number of the valid address ambazo zinakuwa assigned to our network. To our network devices. So our network devices zitaanzia 192.168.10.1.2.3 mpaka 254. Hizo ndo zitakuwa the valid address ambazo zitakuwa assigned to our network. Then let us move to class B network. The class B network, it is a /16 network. It is a /16. So /16 ina represent the first 16 bits, ina represent the network portion, while the remaining parts, the 16 bits zilizobakia, zina represent the host portion. Since our chapter is based on how to find the maximum number of the host per network, so sisi tutakwenda focus only with the host portion. So our target now is the host portion, which is 16 bits from this case now. Very simple. From our formula, 2 to the power of n. What is n? N is the number of bits that are available to our host portion. From this network, how many bits are available to our host portion? Now the answer is 16 bits. Since this one is 8 bits and this one is 8 bits. Once we add them, you're going to get 16 bits. So 2 to the power of 16, then we minus 2. Tunatoa mbili kwa sababu ya ile network address pamoja na broadcast address. Sipotoa mbili, tunapata the total number of address ambazo tumeinclude pamoja network address pamoja na broadcast address. So tunatoa mbili kwa sababu network address na broadcast address, the address they are not going to be assigned to our network address. So once you find it there, you're going to get the total number of the valid address about 65, 53, then 4. This is your total number of the valid address that are available to our network ya class B network ambayo ni 172.32.0.0/16. Now let us look at another example here for class A network. The class A network ni 10.0.0.0/8. So as usual, the first 8 bits na represent this is the network portion, while the remaining parts ambazo ni 24 bits na represent the host portion. So hii ni 8 bits, 8 bits, 8 bits. Ukijumlisha kwa pamoja tunapata 24 bits. Now, our target is to find the total number of the address per network. So from our formula, the 2 to the power of n, then minus 2. N represents the number of bits that are available to our host portion. So for this network, the total number of bits ambazo zinakuwa available to our host portion ni 24 bits. So 2 to the power of 24, then we minus 2. Once again, the reason why tunatoa mbili ni kwa sababu tunatoa network address pamoja na broadcast address. The network address na broadcast address, these are addresses that are not going to be assigned to our network devices. So that's why we have minus 2. So 2 to the power of 24, then minus 2, we are going to put about 16,777,214, about this is the total number which are valid from our network ambayo ni /8. Now I'm hopeful utakuwa umeelewa jinsi ya kutafuta the maximum number of address per network, how to find the first usable address, the last pamoja na broadcast address. The broadcast address inakuwa represented by all ones in the binary codes. Once you convert that number into binary codes, so inakuwa represented by all 1111. So it depends with that network whether it is a /24 network ama ni /16 au ni /8. While the network address kwenye host portion, ukiona kwenye host portion zote ni 00, basi means na represent that is a network ID. So don't forget to watch the next video ambayo finally itakuwa ina focus na jinsi ya kuassign IP address Cisco devices. Thank you for watching my video.